everyone, welcome to my channel. If you like today's video, subscribe to my channel. It will motivate me to do more videos. Let's get into the topic straight away. Let's talk about the second category in this video. So, the question is about differentiate the function with respect to x. So here in this question, if you observe, two functions are together with a minus sign. So whenever we are having two functions or three functions together with a minus sign or plus sign, we have to go for the technique what we are going to learn now. So now what we are going to do means we are going to assume the given to be our y. So let us consider y to be x power x minus 2 power sin x. By taking log on both the sides makes the process tedious here. So we'll consider each function individually as u and v. So let us consider x power x as u and 2 power sin x as v. That means how to interpret the above given function means y is equal to u minus v. So by differentiating this, we will be getting dy over dx, which is equal to du over dx minus dv over dx. We are differentiating v with respect to x, that's why we got dv over dx, and here we are differentiating u with respect to x, that's why we got du over dx. We'll label this equation as star for time being. So now what we are going to do means, first we are going to differentiate our u individually now. So let us consider u here. So u is actually x power x. So here we know that the logarithmic differentiation method says we have to apply log on both the sides. So we are going to take log u is equal to x log x. While taking log, this x comes in front automatically. So now what we are going to do means we are going to differentiate the above equation with respect to x. So let's take the first derivative for the above equation. So which gives us 1 over u into du over dx. Because differentiation of log will give us 1 over that particular value. So that's why we are writing here as 1 over u. With respect to u, we need to do now. Inside function is u, so that we are differentiating. That gives us du over dx. Here on the right hand side, as usual, we are going to apply our product rule. So product rule says whenever two functions are in the product form, eventually it gives us uv dash plus vu dash. So we are keeping our first function as it is, and we are finding the derivative of the second function, plus we are writing the second function as it is, and we are writing the derivative of the first function. So here we'll assume our u to be x. So u dash would be 1. V let us consider as log x. So v dash would be 1 over x. So uv dash, here we need to first write our uv dash. So which is x into 1 over x plus vu dash is log x times 1. So here x is getting cancelled nicely. So we are getting our simplified version as 1 plus log x. and u comes on the other side, so it comes to the numerator as u, and we know that u is nothing but x power x, and we are writing our inside function as it is. So here we are going to label this particular equation as 1. Why we are doing like this means at the final step we will be substituting everything. So we are labeling each and every equation according to the situation. So now next would be our v. So here we have considered our v to be 2 power sin x. So that we are going to write down now. So v is given function which is 2 power sin x. So here we are going to take log on both the sides, log v, and of course sin x comes in front. So this gives us our log 2 as usual. So now we are going to differentiate on both the sides, which is 1 over v. Of course we are differentiating log v, 1 over v times dv over dx. On the right hand side, our log 2 is the constant. So we'll better find the derivative of our sin x alone. So derivative of sin x is simply cos x. So here we are going to bring the v on the other side. As usual, it comes to the top. So here v is nothing but our given function. So finally we happen to get our dv over dx perfectly. So we'll label this as second equation. So now what we have to do means we have to substitute everything in the star equation, because there only we have denoted as du over dx minus dv over dx. So here we are going to substitute our respective derivatives. So let's do it now. So now what we are going to do means we are going to substitute and we are going to see what happens now. So substitute 1 and 2 in star. So therefore dy over dx equal to du over dx, it's our first value. So this I have to write down as it is. X power x 1 plus log x, and in between we have got minus sign, that also we should consider. So I'm going to write down the minus sign in between. And then we have got our dv over dx, which is 2 power sin x, and inside the bracket we have got log 2 times cos x. So this is our final required answer. So whenever 3 or 4 functions together with the plus sign or minus sign, I mean arithmetic operations in between them, it's better to assume them individually and do the differentiation accordingly. Directly, if we are finding the derivative, it will be so tedious for us to proceed further. So that's why we are considering them individually like this, and then we are doing the differentiation accordingly. We'll try one more example. The another example is find dy over dx of the given function x power y plus y power x, which is equal to 1. By looking into this equation, we are so sure that we need to apply log. Since we have got plus sign between, we are going to try in the way what we did earlier. So what we are going to do here, we are going to assume them individually. So let our x power y to be u and y power x to be v. So our given question actually becomes u plus v equal to 1. So if we are differentiating this with respect to x, it becomes du over dx plus dv over dx equal to 0. So this is our first equation. We are going to label them here also, then only it will be easy for us to substitute accordingly. So now we are going to try our u first. So then u would be the given thing. As usual, we are going to take log on both the sides. So it will become log u is equal to y comes in front as we are using log. And now we are going to differentiate with respect to x. So log u becomes 1 over u times du over dx, and which is equal to, yes, here we are going to use our product rule. It's better to go for product rule as they are in the product form. So two individual functions are in the product form, so we'll apply our product rule. So product rule says whenever the two functions are in the product form, we will be keeping the first function as it is, derivative of the second function and plus symbol. We will be writing the second function as it is and derivative of the first function. So this is the pattern, this only we are going to follow now. So here, what is our f? F is simply our first function, which is y. F dash should be dy over dx. So even though in our first equation we didn't get our dy over dx, in our derivative, while we are proceeding further, eventually we get our dy over dx. So now second function we are going to consider, which is g. That is log x. Derivative of log x is 1 over x. So this is the pattern. Let us apply this one in our right hand side. So fg dash. So y times 1 over x plus gf dash. So that is actually log x into dy over dx. We found the derivative perfectly on the right hand side. Now we need to bring the u on the other side, and this will be as it is. So this we are going to write as it is. U here is nothing but our x power y. So x power y, and this we are going to write as it is. So here we'll name this equation as 2. So now what we have to do, we need to think about our v. So v is actually y power x. Let us give a try for that. So now v is equal to y to the power of x. Of course, we need to apply log on both the sides. X comes in front, log y. Now we are trying to differentiate with respect to x. So log v becomes 1 over v times dv over dx. And here on the right hand side, we need to apply our product rule. So we'll give a try for the product rule again, because here also they are in the product form. So yeah, I'll repeat that pattern again. Same pattern, I am repeating it again, and we are going to assume our f to be x, and here g would be log y. And this f dash is so simple one. G dash is, we are finding the derivative of log y. That gives us 1 over y. With respect to x, we are trying to find the derivative of y, means we are getting dy over dx. So this is our derivative. We'll apply our product rule. Fg dash. So that means x times 1 over y. I'll put the y on the bottom. Dy over dx plus gf dash, which is simply log y times 1. So it's better to write log y alone. and then v comes over here on the right hand side. We are writing the remaining stuff as it is. So here v is nothing but the given stuff, which is y to the power of x. So we found our derivative of y also perfectly. The next step is really very important, because we are going to substitute our 2 and 3 in 1, and we need to find dy over dx by simplifying them properly. So let us give a try for that. So now we are going to substitute 2 and 3 in 1. So the second equation was x to the power of y. Inside the parenthesis we have got y over x plus log x times dy over dx. So that I am going to write down as it is, because our first equation, if you observe, that is simply adding them and making it equal to 0. So that only we are going to do now, adding those two derivatives and making it equal to 0. So let us do that now. Log x times dy over dx. Actually this is our d over dx, plus dv over dx is there, so that also we need to substitute, which is actually y to the power of x log y plus x over y into dy over dx, which is equal to 0. Now what we are going to do means, we are going to multiply this function inside the bracket for each and every term. So we'll do like that. So what we are getting, x power y log x times dy over dx. Here y is there, as already x is on the bottom. What we can do with this x, we can write the power as y minus 1. That will do in the next step. Now we'll simply multiply each and every term inside the bracket. So here y power x log y, and this is y power x times x over y dy over dx. In this step, please listen carefully. Here we are going to factor out dy over dx separately. So here we have got dy over dx. Here also we have got dy over dx. So I am going to put that outside as a common factor. Inside we will be writing the remaining stuff, whatever we are getting. So for this one we are getting x power y times log x plus this numerator we can write as it is, but here also y is there, here is also y is there, so we can combine them. So we know that by using the law of exponent, how to consider this. Whenever we are having the base to be same and they are in the fraction form with the different powers, it says that we need to subtract the power. So this rule we are going to apply over here. So by using this law of exponent, what we are getting over here, y power, we are subtracting the power. This is actually x and this is actually 1, this power, so minus 1. We found our dy over dx perfectly. Now next thing is, we have got y here as usual times x. Again we are going to apply the same rule. So here x is there with the power of 1, so it will become y minus 1, because we can subtract the power if we have got base to be same. And this one as it is we are going to write down, and now which is equal to 0. So next step would be, we are going to move this on the right hand side. So altogether 2 terms we have got. This we are going to move it to the right hand side. So the sign changes. It will become minus y x to the power of y minus 1, and here also y to the power of x, minus y to the power of x log y. Here this will be there as it is. We are not going to disturb anything here. We are going to write as it is. Now here we can factor out the minus sign, so that the entire expression becomes yx to the power of y minus 1 plus y to the power of x log y over, this comes down as the denominator on the other side. So x to the power of y log x plus xy to the power of x minus 1. Because this expression is in the product form with your dy over dx. While we are moving this on the other side, it will become the denominator. We are undoing the operation. So while we are moving this on the other side, it becomes the denominator. So this is our final answer. I hope this is useful to you. Thanks for watching. Until next time, take care. I'll be coming with the part 3 video very soon. So until next time, take care of yourself and subscribe to my channel. Thank you.